How can submarines stay underwater for 120 days? Where does the oxygen inside them come from? This is the Typhoon-class submarine, the largest submarine in the history of the world. It measures 175 meters in length, 23 meters in width, and 11 meters in height, weighing 48,000 tons. If you take it out of the water and put it on land to compare it with a building, you will see that it is bigger than a building. It is such a huge machine that can carry hundreds of people to 250 meters below sea level for 120 days or more, with all the life facilities on board, such as gym, bathroom, kitchen, etc. To allow more than 100 crew members to live underwater for so long, the submarine has two methods to produce oxygen. The first is a water electrolysis device. The device is divided into two tanks, one positive and one negative, and just fill with purified seawater and electrolyte and pass an electric current. The positive pole will turn the water into oxygen and the negative pole into hydrogen. The oxygen and hydrogen produced by electrolysis will be purified and cooled in the separator, and then the oxygen will be transported by pipes to the various chambers of the hull. The device can provide 4,000 liters of oxygen per hour for the submarine, and the hydrogen will be released to the outside of the ship. The second method to produce oxygen is to burn chlorate candles, which are solid candles that contain iron and sodium chloride. When heated, they release oxygen. This device does not require electricity and has a small size, a large amount of oxygen, and is often used in spacecraft. The Typhoon-class submarine, as the largest submarine in the world, also has a nuclear propulsion system, which only needs a little uranium fuel to operate underwater for 20 years. How does such a powerful nuclear reactor provide energy? This is the reactor container, which contains tens of thousands of fuel tubes, each containing uranium fuel processed into small grains. When neutrons hit the nuclei of these uranium fuels, they produce a fission reaction, releasing 2 or 3 neutrons and 200 million electron volts of energy. And the split neutrons will continue to bombard other uranium elements, producing a chain reaction that will make the fuel tubes generate a lot of heat, which will then be transferred to a steam generator through heating high-pressure water. In the steam generator, the heat will boil the water and turn it into steam, and the steam produced will enter the turbine through a pipe, making the turbine spin and drive a huge gearbox, and finally, its energy will be transmitted to the propeller.